So is it possible to take this off-the-shelf UTV winch and turn it into a chainsaw-powered pulling machine? So on today's episode of I Want a Chainsaw-Powered Winch, we're going to take a crazy idea and bring it to reality. So the primary motivation for this project is to try and make a gasoline-powered winch that doesn't cost $800+. Now you can get one of those Lewis winches which look like a really solid product, however, they cost just a bit out of my range.
The price is too damn high.
So we've got the next best thing, a Harbor Freight winch and an extra chainsaw. The 5,000 pound might be slightly overkill, but that's not a bad thing, other than throwing your back out when you're trying to lug this thing along. So the first thing we did is buy this winch whenever it was on sale, and then let it sit over in the corner until all of the warranty has expired. That's not really a bad thing though, because, well, we're going to destroy the warranty anyways. I mean, you got to be part of the reason that they actually have warranty stipulations. So there's like all of these electrical type stuff and connections, cables. We don't need any of that. We're going straight hydrocarbon power.
How dare you?
So once you get rid of all of the excess, well, that's still pretty heavy. Just start working out, I guess. But there will be a significant portion of this that disappears when you go to gasoline power. Now, believe it or not, we actually did some research on this. You can download the manual here online before you buy it. And they've got a nice diagram showing exactly what's inside. And since we're going to remove the electric motor portion of this, we only need the gear reduction system to actually drive the cable. Now that's a good thing, having all of the gear reduction over here and the connection between free spool and drive all located on that side. That means that we only have to replace the driving power source here. And that's what we're going to do with the chainsaw in the form of a pulley. Now I'm guessing that the most challenging part is going to be having a bearing support and some type of way to actually drive the through shaft that goes underneath the spool there over to the gear reduction drive. If you can bridge that gap, you've pretty much got it licked. Well, that's enough talking about planning. Let's start tearing this thing apart. And we've immediately found out how to change the brushes. And with those two bolts, we've basically got the motor separated. Now you look inside there, there's the drive that motor shaft runs, which that looks to be a plain bronze bearing. Normally this motor here doesn't see a whole lot of side loading. However, when you try and hook a chainsaw up to it, it's definitely going to want to pull to one side. That's going to take some thinking. We're going to have to come back to that. Now this whole contraption here, this is an old steel 029 chainsaw that I have previously converted over to a chop saw. And it's worked well, but in the meantime I ended up getting a much larger, legit steel chop saw. So we really don't use this a whole lot. Time for this thing to get repurposed. Now the key feature on this chainsaw is the clutch here that I have welded a V-belt drive pulley onto. Now we'll give you a brief overview of how this was done. So if you don't just happen to have an entire scrap pile laying around that you can source pulleys from, this is about the cheapest pulley right here I found that gives you a metal V pulley about 3 inches in diameter. That's what we got welded on the old 029, which actually uses a slightly bigger drum than the 026, but it'll still work. So there's the drum off the 026. We just got to grind off this lip here and knock that bearing out. On the bigger pulleys you can just weld it around the outside, or like this one you can kind of weld around where the bearing was seated. Saws with the clutch and the drum outside the chain drive, well, those get a little bit more tricky. It's going to be a custom operation to do this. One option could be, instead of welding the pulley directly onto the drum, you may be able to attach one of the sprockets centered up in there, and then you can kind of drop it onto the drum just like it would from the factory. And another option altogether is to actually find a clutch and drum off of a concrete or demo saw. They already come with a V-drive a lot of times. Some of the newer ones are serpentines, but if you can find a cheap used one or a cheap aftermarket that you realize is going to actually fit the threads correctly on your crank output, you might be able to just buy a factory option to convert it to belt drive. Now, just visualizing at this point, but that's probably going to be how it's set up. So what I'm thinking is, you got the winch here, the fair lead up front. We'll have to get a drive system to drive the gear reduction, and then we'll have a strong back plate or some type of a connection here all the way to the back where there's a shackle that you can anchor this thing to a tree or rock or whatever. The drive direction of the chainsaw in relation to the winch actually means that it's going in the right direction. Kind of hard to see, but it's getting there eventually. Just trying to sort through the pieces of scrap and see what'll fit. Just kind of getting things mocked up. Now, the whole basic concept is you need to get the winch this way and down. It's a little bit of a free-form activity. Use your imagination. Just find whatever scrap steel you have laying around. It doesn't have to be pretty. You just need to have a fairly solid connection between the base of the winch and the chainsaw here. The belt drive connection of the two is really the only thing pulling these together here. All of the force of the winch is going to go directly from the cable into it and into your mounting point out the back. Now, on the underside, we're going to get a flat bar, weld it probably or bolt it, whatever, to this base plate of the winch, extend it beyond the back of the saw, and put a clevis right there. One of the most critical parts of this whole thing is how are we going to hold the bearings? Trying to find an off-the-shelf bearing holder for this application is not as easy as you'd think. This is actually a safety railing mounting base. Looks like a hub now. Parts like that, railing hub, specialty bolts. Man, you can spend hours just cruising through the online McMaster car catalog, finding random bits of stuff to use for their non-intended purposes. You got to be a little bit wary though, because this was actually the first hub that I'd bought. It's made out of cast iron, cast steel. Thought it was going to be the right shape and size. The dimensions online showed a bore size that would just fit some other stock bearings, 1 5/8 OD I think they were. But if you look close, the inner diameter was only on those raised sections. So the whole rest of the inside, no good for our use. But since we'd already started grinding on this thing, no more returns. We'll drop it off in inventory. So this hub right here really needs machined on the ID to open it up to fit those bearings. However, we don't have a lathe. I mean, sorta, but that really doesn't count. So we spent a bit of time thinking about how long it would take to try and grind the ID of that to the proper size for the bearing. A lot more direct route is going to be taking these bearings and grinding the OD down to the right size. Now, luckily, I ended up buying a 10-pack of these because, well, everything gets cheaper in quantity. So we're going to give it a shot on external machining. You want to keep the sparks kind of even. Grinding the bearings took like 3 minutes instead of a half hour drilling out the hub. Now when you're grinding down a bearing like that, you got to take your time a little bit. You don't want to put too much heat in here and take the hardness out of the races. If you even start to see any blue and temper marks developing on the steel, it's gotten too hot. So just take a little bit at a time. To replicate that semi-square drive right there, we'll just take a bolt and grind it to fit. So we've got the aluminum new hub here, getting it fit up. The holes didn't match, but that's what drill bits are for. Able to reuse all of the existing threaded holes for attaching the hub. And what we're going to do is have the bearings set up on the drive shaft like that. They're spread out by this spacer tube. Now when these bearings on the shaft get slid down into the hub here, and then we'll tighten down these two set screws. So we'll have a bearing, spacer, bearing, and another nut to hold it all together. And that set screw will hold this bearing here and keep the whole shebang from flying off, hopefully. Now the whole point of having this hub out here is so we can use two bearings and keep them spaced as far apart as possible. That gives you more support when you're trying to pull on the belt pulley back like that. Now I was going to end up using this bolt, but found out we needed a fully threaded thing here to basically hold all the components together. And after taking some measurements and duplicating that sort of square drive, it mates up right with the drive gear inside the winch. So we measured once and we're grinding twice to get some extra clearance. Yeah. Now there's a good chance that you wouldn't have had to do as much grinding as I had to if you did just measure the bolt length correctly first. This thing's about 3/16 of an inch shorter than it could have been, which would have actually spaced the pulley out a little bit further, but So the pulley's off of a small block Chevy. I believe they consider this a long water pump, but whatever. There's two different styles, but this one's pretty obviously, you can tell by the shape of it. Only concern I have about this is the lack of support on the inner structure right here. Normally the water pump would be bolted further out on this metal piece. You're going to get some flex and some kind of deflection on this when the pulley's getting pulled to the side. So if this starts flexing and coming out of alignment, we may have to weld a washer or something around the outside here. But we're just going to run it for now and see what happens. We put some poor man's Loctite on those threads. A few tack welds ought to hold this for now. Yeah, that alignment looks right. Yeah, that'll clear itself up. There is a slight bit of concern about the automatic brake that is within these. Probably mentioned it already. One of the main reasons I chose the 5,000 pound in this style is that all the gear reduction is over here in this side, and you just have the motor input over here. Some of the winches have another planetary gear reduction sort of bolted on this side, and then a drive shaft that goes through the middle of it. We don't want to deal with all that. But there still is a brake somewhere inside the drum here that I'm not exactly sure how it works. We'll have to look at the manual. Well, who looks at the manual? You could potentially run into an issue where winch is engaged, you've got a load hanging on it, and you basically need to take the tension off the cable before you can release this thing to get it to unspool again. And if that happens, we'll just go in here and completely disable that brake and use the kickback brake on the chainsaw as the holding mechanism. Drilled a couple of holes, made that main slot for the bolts on the chainsaw bar, and then added an adjustment hole right there to use the existing tensioner on the chainsaw. Definitely got to drain all that bar oil out of there. The roller fairly just bolts onto the standard mounting plate. So luckily everything's just tacked up here, and we welded the angle directly to the base plate. We might have some interference between the belt coming through here. So we're going to basically break those tacks and drop this thing down a little bit more to try and keep the belt centered with on this frame here. We'll figure out how to run that thing eventually. Nothing the grinder can't take care of. That should hold. So at this stage, we're realizing that a lot of this heavy angle and plate is probably unnecessary. So that about does it. Bunch of ugly welds later, finally got that thing bolted on. Now obviously the origins of this project started from not wanting to pay full retail price for one of the production style chainsaw winches, but it was also a mission. Sometimes when you just get an idea, you gotta follow through with it. Might not be the most easiest or efficient route, but you gotta prove a point. And one of the key features of this whole thing was trying to make that hub area down there to transmit power from the chainsaw into the drive on this winch. Could have started off from complete scratch and just started fabricating, you know, cutting things, grinding down shafts, just welding everything up. But I thought there had to be a way to use some sort of off-the-shelf parts as a good starting baseline. I mean, you can make anything fit another part with enough welding and fabrication. That was sort of the route that we went when I converted that air compressor over to chainsaw power. At the end, it was a ton of work and a lot of really customized parts that weren't a great fit to just do an easy conversion. A base setup like this is always going to be slightly different for each different individual saw, but the overall concept is basically the same. Just go to your random belt pile to find something that'll fit. Doesn't matter how many parts you have, it's never the right one. $4 belt, fresh off the internet. Now the 340 belt was too long, and the 330 belt, well, it just barely fits. Just like mine after Thanksgiving. We're going to totally rig up an ISR approved belt guard over here. Definitely not just operate it from this side. Well, alright, time to try this thing out. Well, that was a full load test. We started straightening out the bar on the bottom side. All 4 tires locked up. It's no 9,000 pound winch, but it'll get the job done. So I would say that the unfinished and unpainted status of this right now is just for testing, and we'll come back and finish it. But as long as it doesn't break, it'll stay this way. Temporary is just one test run away from permanent. And because it never fails, if you actually finish a project, it's just bound to break. Leaving things in a perpetual state of shambles means you never have to feel bad about working on it. It's like riding a 3-wheeler. You're always on the edge of being out of control. It's no surprise when you finally barrel roll it down a hill.